Suppose we have two vectors u and v in standard position. We want to be able to write u as the sum of two vectors, a and b, such that a is parallel to v and b is orthogonal to v. The vector a is known as the projection of u onto v. The vector b is known as the projection of u orthogonal to v. We can see the symbol for each of these here. We can write the vector u as the sum of the projection onto v and the projection orthogonal to v. We then take the dot product of both sides of this equation with v. Since the dot product of orthogonal vectors is 0, we can ignore the final term. Since the projection onto v is just a scalar multiple of v, we can rewrite the right-hand side as SV dot v. Since v dot v is the square of the magnitude, we can solve for s to get that s is equal to u dot v over the magnitude of v squared. Since the projection onto v was given by SV, we have the projection onto v is given by u dot v over the magnitude of v squared times v. We also have that the projection orthogonal to v is given by u minus the projection onto v. As an example, let's suppose u is equal to -1, 8, and v is equal to -6, -8. You can check for yourself that the dot product of u and v is -58, and the magnitude of v squared is 100. Then the projection of u onto v is given by -58 over 100 times -6, -8, or the vector 3.48, 4.64. The projection orthogonal to v is then given by u minus the projection onto v, which is given by -4.48, 3.36.